Welcome to this AP guided practice on mass spectroscopy of elements. Really what we're attempting to do here is to determine what the average atomic mass is. And sometimes we're given this information in just a written format, and sometimes we're given this information, like in number 1, in some type of a graph. And so we want to be able to take that information and apply it in some different ways. So the first thing that we need to know is that the abundance is actually percent. So we'll put percent over here. And we could see the mass values either as the actual mass values, or we could see them as the mass number, which is what we have in this particular case. So these are our mass numbers. Okay. Now when we look at this, we notice that neon 20 is the most abundant at 90.92. So we would expect that in this particular case, whatever our average atomic mass is going to be closest, right? So the average atomic mass is going to be closest to 20, okay? So closest to this because it's the most abundant. Now we can't just find a normal average like we would with equal proportions. We actually have to take these proportions. So that's what we have to do. We're going to make the percent for each one of these. So we're going to make the percent a decimal. Just move your decimal 2 places to the left or divide by 100. Whatever you like to do. And then we're going to multiply it by the mass, and in this case it'll be the mass number. So we're going to take for 20, it's 20 AMU, 20 AMU times our abundance, so 0.9092, okay? And we'll find out what that subtotal is here. My hand keeps hitting my screen just a little bit, so that's going to be 18.184. Now, if I'm actually doing this, I'm probably running all of my numbers in the calculator at once, but just to show the stepwise process for this, I'll do each one individually. So let's go ahead and take neon 21. It's the smallest amount of any isotope of neon that is naturally occurring. So 21 AMU times 0.0026, and we get a very small value here, 0.0546. And then finally, for the last one, we have neon 22. It's almost 9% of the naturally occurring neon that we see. And so we're going to have 22 AMU times 0.0882, and that gives us a value of 1.9404. Now remember, those were all in AMU. Now to find out what our actual average atomic mass is, maybe I should underline this in this color, we're going to go ahead and add all of these up. So we're going to add them up, okay, and we end up with 20.18 AMU. Now, if we're talking about 1 mole of neon, then of course that could also be grams per mole. Okay, so we can also put or grams per mole for the unit, because that allows us to do some additional work here. All right, so let's go ahead and take a look at question number 2. Once we know that average atomic mass, then we can actually use it to do some conversion work. And so in number 2, neon signs light up when plugged into an electrical outlet. If there are 2.3 moles of neon in a particular sign, what is the mass of the neon in the sign? If we wanted to know that, okay? So let's go ahead and start with that amount. 2.3 moles. Okay, so we're going to do 2.3 moles. And we said we had 20.18 grams per mole. So let's go ahead and put that into a conversion factor here. So for every 1 mole of neon, we know that there are 20.18 grams. We have 2 significant digits in our 2.3 moles. We're going to round to 2 significant digits in our final answer. So that should be 46 grams. Now, what if we wanted to know the number of neon atoms? Well, we would go a different direction. So we're going to start with our 2.3 moles on part B again. But now we want to actually know the number of atoms. And so to know the number of atoms, we want to make sure that we use Avogadro's number. So now we're going to plug in, 6.022 times 10 to the 23rd atoms for every 1 mole of any substance. Again, let's round to 2 significant digits since we started with 2 sig figs for the number of moles, and we should get 1.4 times 10 to the 24th atoms. All right. So there we were able to determine the average atomic mass based on abundance and isotope mass, and then we were able to use that information to further know more about a substance. Take a look at some independent practice and work through some additional problems.